Today, I'm going to teach you the periodic atomic properties step by step using simple logic, not memorization. And before I continue, let me say this here. If after you finish watching this video, and yes, you just can understand this topic very well, I am able to solve questions under this topic, please also subscribe to this YouTube channel, right? That is the promise I'm giving to you. So in this video, you will learn why the atomic radius changes, why the ionization energy rise and fall, and how you can predict any element behavior just by the position. So grab your pen and notebook. Now let's start for the foundation. Majority of students who want to understand this topic don't really understand the foundation, and most textbooks don't actually understand, don't actually explain the foundation. So I'm going to explain that to you, because every trend in the periodic table comes down to these two main big ideas, which I call the foundation. So now let's look at the foundation, why the atomic properties changes, because large majority of students don't really understand this part. And if you can understand this, what I'm going to explain to you, then every other thing in this video will be more easier for you, right? So here we have two key facts, which called the nuclear charge. Nuclear charge means what? Numbers of protons, which I'm going to explain. Number two, numbers of share. This number of share means what? Shielding effect. It's called what? Shielding what effect. So now let me explain to you. Now what is nuclear charge? Now nuclear charge is the force, or is the attractive force in which what? The nucleus used to attract the electron. That is called nuclear charge. Is that attractive force in which the nucleus used to attract the electron in the shell. Please take a look at the shell. Now let me explain to you. Now remember, if you look at the structure of the atom, here we have the nucleus. The nucleus contains the proton, right? Now let's say this is what is the proton, right? And let's say this is what is the electron, right? Now remember, the proton is positive charge, while the electron is negative charge, right? I know that in physics, the positive and negative, they attract each other, right? So the force, this attractive force in which the proton pull the electron from the shell is called the nuclear charge. It's called the nuclear charge. It is what? It is the attractive force in which the proton pulls the electron from the shell. And is determined, the attractive force is determined by the numbers of protons in the nucleus. So the more the proton, the higher the nuclear charge. The less the proton, the less the nuclear charge. Now when I talk about the nuclear charge, I'm talking about the attractive force in which the nucleus used to pull the electron. And what made the nucleus to pull the electron from the atomos shell is due to the proton inside. So when you talk about the nuclear charge, what should come to your mind is numbers of protons in the nucleus, and it is the attractive force. So there's one thing to understand here. This is thing to understand. One, the more the proton number, the higher the nuclear charge. Very important. The more the proton number, the higher the nuclear charge. Another thing is that the higher the nuclear charge, the smaller the size. So from here, you now get here, the higher the nuclear charge, the higher the nuclear charge, right, which we call the attractive force, the smaller the size of the atom. Come on, the smaller the size of the atom. So please, they go hand in hand. Please take that share. They go hand in hand. The more the proton number, as the proton number increases, the higher the nuclear charge, And I told that the nuclear charge is that force that pull that in which what the nucleus used to pull the electrons, the electron share to itself. So the more the pulling effect or the pulling force, the smaller the atom. So this are things to understand it. The higher the nuclear charge, remember I told you that the nuclear charge is the pulling force in which the nucleus used to pull the electron from the what outermost electron, right? The smaller the size. Now, on the other hand, when you start, the less the proton number, the less the nuclear charge. Just another thing you need to put in mind, please take this down. The less the proton number, the less the proton number, please speculate here, the less the proton number, then the smaller the proton number, the lesser the nuclear charge. The lesser the nuclear what charge. And what happens to if the nuclear charge reduces? So the lesser the nuclear charge, the higher the size of the atom, the larger the size of the atom. So the less the proton number, the lesser the nuclear charge, which means the higher the atomic size, which means the higher the atomic size. So please, these are things you need to put down inside your notes very well. I'll go over it again. Let me explain it again. Remember I told you that there's always a force, there's only that attracting force in which was the nucleus is to put the electron. And that force is called nuclear charge. And what controls the nuclear charge is the proton number. Just so in the sense that, please pay attention here. If for example here we have two atoms. For example, here we have two atoms. Here we have atom A with 5 protons, and atom B with 10 protons. Now, which one we have more nuclear charge? Which one we have more nuclear charge? Talk to me. Which we have what more nuclear charge? Now, the one that we have more nuclear charge is the one that have more proton. So this guy, atom A, we have more proton, right? Good. If atom A have 10 proton and atom B have 5 proton. Now, according to what I've written there, the higher the proton number, the higher the nuclear charge. Okay, the more the proton number, the higher the nuclear charge, right? The higher the nuclear charge, the smaller the size of the atom. So atom A and atom B, which should have the smaller size? I'm asking you, which should have the smaller size? The smaller size would be what? Atom B. Why? Because there's a greater pool of electron there. So in the sense that if you compare the size of these two here, this guy might be like this, and this will be like this. Why? Because this will have more proton and more greater pool of electron from the nucleus. So the size will be smaller. Now, compared to this one, this will have only 5 proton. So the size, the pulling effect will not be more compared to this. So the lesser the proton, the higher the size, right? The more the proton, the smaller the size, due to what? Nuclear charge, the mass of proton. So these are things you need to understand when it comes to what? Nuclear charge, which called numbers of proton. If you understand this here, then you can understand what is called atomic size, ionization energy, and the rest. The next one to look at is what? Numbers of shell. Let's look at what is called the shielding effect. Look at that. So now number 2, numbers of shell, this is called the shielding effect. Please pay close attention here. Please, if you understand the first one here, let me make sure that you understand the first one, which is called the nuclear charge. Because if you don't understand that, you may not understand any other thing again. So if you understand the first one, which I've explained, which is called the nuclear charge, please let me make sure that you understand. And if this video is helpful, please, one of the things you do to support this YouTube channel is by liking and subscribing and sharing this video. So if this video is helpful, please like and subscribe and say this video is helpful, and I will appreciate that. Right? So let's continue here. Numbers of shares called the shielding effect. Now, remember, we have the nucleus, right? And we have what the shell. So here is what is nucleus that contain the proton, although the nucleus contain the proton and the electron and the what neutron, right? But let's say this is what is nucleus, right? And here we have the shell. Now, as the numbers of shell increases, remember, if we have one, if now this is the nucleus, right? The nucleus contain the protons, right? They contain what the protons, right? Now, let's say this is the outermost electron. This is the outermost electron, right there. So the numbers of electrons here, if for example here we have the nucleus, and we have the first shell, we have the second shell, and we have the third shell. Now, you can see that as the numbers of shell increases, the size of the atom increases. That is what you need to understand here. As the numbers of shell increases, as the numbers of shell increases, the size of the atom increases. The size of the atom increases. This is what you need to understand here. And our main aim is outermost electron. If you look at it very well, because if you talk about the shielding effect. Now, if you compare this guy, this is the nucleus, and you compare this one here, that have only what one shell. This is the nucleus. This is what is nucleus. If this guy you have only one shell, please pay attention here, which is the electron. Now compare these two things here. Here's the nucleus. Here is what is the electron. You can see that because it is having only one shell. Now the attractive force is more here. The attractive force is more here. Like the nuclear charge is more here. Because why? The shell that holds the electron is closer to the nucleus. Now, because it's close to the nucleus, what happens here? There's a great force. There's more force. The nucleus can attract it. So there's higher nuclear charge here, but there's lesser nuclear charge here. If you compare this one here, if you look at the distance between this guy and this guy here, the distance is very high. Just another thing is that the main reason why it's called shielding effect is that now, if you look at this shell here, before you get a nucleus, you have to pass this guy and pass this guy here. So these two are shading this outermost electron here, whereas there's no shading. So this is what you need to understand here. As the numbers of shells increases, the size of the atom increases. So the higher the more this shell, or the more the atom of the shell, the more the shell of the atom, whichever way, the more the shell of the atom, the bigger the size of the atom. This is what you want to understand here, right? As the numbers of shell increases, the size of the atom increases. The size of the atom increases. Another thing here is that as the numbers of shell decreases, as the numbers of shell decreases, what happens to the size? What happens to the size? What happens to the size? The size decreases. The atomic size decreases. So these are things you need to pay close attention to. You understand? These are things you need to pay close attention to. You need to pay close attention to this thing here. So now let's look at what the first one. Let's look at the first one. Let's look at what the first one, the atomic radius, which is called the size of the atom. So now the atomic radius is equal to what? Distance from nucleus to the outermost shell. the distance from the nucleus to the outermost shell, and I will explain to you here. So if you have an atom like this, the distance between the nucleus and the outermost shell is called the radius, right? Remember, when we talk about circle here, the full one is called the diameter, while the half here is called the radius, right? The radius is the size of the atom. That is called atomic radius, which is called the size of the atom, right? So now when you compare two atoms, here we have this one and here we have this one. So the smaller the size of the atom, the smaller the distance between the nucleus and what and the shell, right? Now, but the bigger the size of the atom, then is the greater what the distance. So if you compare this one here, A and B, right? You can see that as it get bigger, as the size get bigger, the further the nucleus and the shell. Now as it gets smaller, the distance decreases. So there are two things you need to pay close attention to: size A, size B. This one is bigger the further it is, right? So you can see that the shell is not close to the nucleus, that why it's bigger. But here the shell is close to the nucleus, that is why it's smaller. That is why it's called the atomic size. Now you have to look at it: atomic radius across the periods and atomic radius down the group. Very important. So what happens to the atomic radius across a period? Atomic radius down the period. That's why it's called the periodic trend. Atomic radius across the period. So let's say across the period. Atomic radius across periods. Now, please, if you have not watched my first video on periodic table, please do it to watch that video. Now, the video is only available to my students who are paid for that class, who are paid for my class. Just now. Now, if you're in my paid class, the video is already there. Probably you have watched that video, right? Now, this is what the second video. Now, for those of you who have not joined my private class, do it to join my private class. If you are writing the upcoming JAMB or you are writing any science exam at all, please make sure you join my private class so you have access to our complete 90-day system that will help you from beginner to a very sharp student. So if you have issue with your chemistry, physics, biology, and mathematics, join our private class. Just join our private class, which is going to be of great help to you. Now let's look at what across periods. What is the periodic trends or atomic radius across a period? Now remember, when we talk about across a period, I told you that elements that have the same periods have the same numbers of shell. Let me explain to you here. So now remember here we have let me just draw the periodic table. This is the periodic table. For those of you who have watched my video, you already have knowledge of the periodic table, right? So here we have this is a rough sketch of the periodic table. This is just a rough sketch of the periodic table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is a rough sketch of the periodic table, right? So now there's one thing to understand here. Okay, there's something to understand here, right? Now we have to call across a period, right? That is like this. Element across a period, element that have the same period, have the same numbers of shell, have the same energy level. So for example, here we have hydrogen, helium, lithium, beryllium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? Here we have sodium. Here we have what? Sodium. Here we have potassium. Here we have sodium. Here we have magnesium. Here we have what? Magnesium, aluminium, silicon, phosphorus, right? Here we have phosphorus. Here we have uh phosphorus. Here we have sulfur. Here we have chlorine. Here we have what? Argon. Here we have potassium. Here we have calcium, right? Now, this is the periodic table. So in the sense that elements in the same period have the same energy level or the same shell. Just now, remember the shell means what? The same energy level. For example, element in period one. If you look at element in period one, right? Hydrogen, the atomic number is 1, right? That is, you can have it like this. You can have 1x1, right? For the hydrogen. For the helium, you have 1x2. Now, for those of you who have not watched my video on electron configuration, writing electron configuration, please go and watch those videos. They're very, very important. Chemistry is interconnected. That is why you want to have a system. You want to have a system that takes step by step. Now, for those of you who are not in my private class, on the more serious note, you are missing a lot. Because there are some things you are supposed to learn before now that you have not learned. So it makes it more difficult for you. It makes it more difficult for you. So that is why you want to join my private class. Let's continue here. So now, it is saying that element in group one have one shell, like this. One x2, one x1, one x2. So they have only one energy level. They all have only one energy level. So the electric configuration of hydrogen is one x1. Why for helium is one x2. So they have only one energy level. So you say that they have the same energy level, but the electron increases. So for here we have one x1, one x2. Now this for hydrogen, this for helium. Now they have the same energy level, which was the same shell, but you can see that the numbers of electrons, as the numbers of electrons increases, also the numbers of protons also increases. I know that the size of the atom depends on what? The numbers of proton. Because the higher the proton number, what happens? The higher the proton number, the smaller the size of the atom. Like what I said, the higher the proton number, which was nuclear charge, the smaller the size. So if you compare this guy and this guy here, helium, we have smaller size compared to this. So you have this guy can be like this and this guy can be like this. It's okay. Why? Because, sorry, this guy can be like this and this guy can be like this. Why? Because there's an increase in proton number. There's an increase in proton number. Now let's look at what the second energy level. Element in second energy level. Here we have lithium. If you look at lithium is 3. Lithium is 3, right? Now, is what? Is 4, right? Now, boron is 5, right? Carbon is 6. Nitrogen, let's just say nitrogen is what? Is 7. Oxygen is what? Is 8. Fluorine is what? 9. Neon is 10. Now look at something here. If you check there, they are all in same period, right? They are all in the same period because here period 1, period 2. So element in period 1. So here we have element in period 1. They have the same period 1 1. So let's look at element in period 2. So here we have lithium here. Let's get the electric configuration. So here we have 1x2, 2x1. Do you see that? 1x2, 2x1. The energy levels, there is second energy level. Do you see that? Now look at this guy here. Here we have 1x2, 2x2. We also have what? This energy level here, right? 2x2. So let's look at what? Boron. Boron is 5. Here we have 5. So here we have 1x2, 2x2, 2p1. 2p what? 1. For those of you who know how to write the list configuration, 1x2, 2x2, 2p1. For carbon, which is 6. For carbon, which is 6, 1x2, 2x2, 2p2. This is that 2p what 2. So here we have 1x2, 2x2, 2p3. Right? Now here we have 1x2, 2x2, 2p what 4. Here we have 1x2, 2x2, 2p5. Here we have 1x2, 2x2, 2p6. Now, what is similarity here? Now, they are all second energy level because if you check here we have 2x2, 2s2, 2p, 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 and 2p. So the difference here is that these two are actually what in block what X. These two are actually what in block X because if you look at the block here, lithium and beryllium, they are in block what X. Now, but for boron to nitrogen, from boron to nitrogen, they are in block what P. That's what you're seeing here. But we can see that they have the same energy level. Just now. So in the sense that as we move from left to right here. Now, what is proton number here? Yeah, the proton number here is 3. Proton number here is what is 4. Proton number here is what is 5. Proton number here is what is 6. This is that. Now, proton number here is what is 7. Proton number here is what is 8. Proton number here is what is 9. And proton number here is what is 10. Just that proton number here is what is 10. Now, remember, as the proton number increases, what after the nuclear charge? The nuclear charge increases, right? And as nuclear charge increases, what after the size of the atom? The size of the atom decreases. Just so in the sense that as we move from left to right, please pay attention, across a period, as we move from left to right across the period, the size of the atom decreases. That I want you to understand here. Please take it down. As we move from left to right across the periodic table, the size of the atom decreases. Now, why? Because the proton number increases. That is why I say that you must understand what's called the nuclear charge, which is called the proton number. It works across what the period. So the nuclear charge works across the period because why? The elements in that same period have the same energy level. The only difference here is that you keep on adding what? Proton. You keep on adding proton. So yeah, the proton number here is 4. Here the proton number here is what? Here the proton number here is 3. Here the proton number here is 4. Here the proton number here is 5. Here the proton number here is 6, 7, 8, 9, and 10. So across the period, the proton number do what? The proton number increases. And as the proton number increases, the nuclear charge of the atom increases. And as the nuclear charge of the atom increases, what happens to the size of the atom? The size of the atom decreases. So in the sense that, yeah, you can say that, let's arrange it because sometimes in the exam, say, arrange these elements according to what? According to what increase in atomic size or decrease in atomic size. Please look at something here. So here you can see that. So there you want to understand here. The atomic radius decreases from left to right across the periods. So in the sense that when we talk about the atomic radius decreases from left to right across the period. And you now know the reason why. One of the reasons is because the proton number increases. And the more the proton number, the higher the nuclear charge. And the higher the nuclear charge, the more the attractive force. That is why you need to understand this very well. So here we can see that the atomic radius decreases from left to right across the period. So as we move from lithium to fluorine, it decreases. Right? Now, But most of them make the mistake. They don't know how to arrange it in ascending order or descending order, right? And I will explain that to you here. How do you arrange the element now in ascend? Because if you look at it here, for lithium to beryllium to boron to carbon to nitrogen to oxygen to fluorine, what happens here? It what? It decreases, right? So from lithium to what? To beryllium to boron to carbon to nitrogen to oxygen to what? To fluorine. As you move from year to year, it decreases. The size decreases. Now, how do you order it? Right? We're talking about decrease. We look at increasing and decreasing order. So look at what increasing and decreasing order. So now, most students will say this in here, but let me explain to you. We're talking about increasing order. For example, you have 1, 2, 3, 4, and 5. From 1 to 5, is it increasing or decreasing? Let me ask you here. From 1 to 5, is it increasing or decreasing? Of course, it's increasing. That is ascending order, increasing, right? So from 1 to 2, is now if you want to use the sign greater than or less than, what up here? 1 and 2. Is 1 greater than 2 or less than 2? Of course, 1 is less than 2. So 1 is less than 2, 2 is less than 3, 3 is less than what? 4, 4 is less than what? And 5, right? So that is from year to year, they are talking about what? Increasing order, increasing order, increasing. We are talking about what? Increasing what? Order. So from 1 to 5 is called what? Increasing. So what sign are you going to use? Is lesser than. So 1 is less than 2, 2 is less than 3, 3 is less than 4, 4 is less than what? 5. So it's increasing what? Order. Now if you reverse it, we have 5, 4, 3, 2, and 1. What happened here? Like I said, 5 is greater than 4. So what order is this? You should consider is decreasing order. This is called decreasing order. So what sign are you going to use? Is it less than or greater than? Of course, 5 is greater than what? 4. 4 is greater than what? 3. 3 is greater than what? 2. 2 is greater than what? 1. So yeah, we can say that is what is decreasing what order. This is that. So remember, the atomic radius decreases from left to right across the period. So now let's arrange this here in increasing and decreasing or increasing and decreasing order. So let's look at it very well. So understand that as you move from left to right, it decreases. The size decreases. What happens here is that lithium, if you compare the size of lithium and beryllium here, the size of lithium is greater than what? Beryllium, right? So if you look at what? Lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, they normally ignore the what? The group 8. So in the sense that as move from left to right, it decreases. That is, this guy size is far higher. So yeah, this is what is smaller size. This one, fluorine, have the smaller size. So you can see that lithium is greater than what? Beryllium. Beryllium is greater than what? Boron. Boron is greater than what? Carbon. Carbon is greater than what? Nitrogen. Nitrogen is greater than what? Also greater than what? Fluorine. This is that. So that is why you must understand this concept very well. Lab result of don't really understand. So that is why there are issues with it. So that is, yeah, from here, decreasing order. Decreasing what? Order. Decreasing order. Here we are what? Decreasing what? Order. So lithium is greater than what? Beryllium. Beryllium is greater than what? Boron. Boron is greater than carbon. Carbon is greater than what? Nitrogen. Nitrogen you get that oxygen, also you get that fluorine. It's called decreasing order. Decreasing order. If you reverse it here, you have fluorine, oxygen, nitrogen, carbon, boron, beryllium, and what? Now, fluorine is the smaller size, so it's less than. Fluorine is smaller size, so it's less than. Fluorine is less than oxygen. Oxygen is less than what? Nitrogen. Nitrogen is less than what? Carbon. Carbon is less than what? Boron. Boron is less than what? Beryllium. Beryllium is less than what? Lithium. So what order is this? It's increasing order. Increasing. So you must understand this thing. You must understand this concept very well. You must be able to what? Arrange the size of the atom in increasing or decreasing order. So in the sense that across the periods, if you go across the period, because also I will call down the group, which I'm going to look at. Now you go across the period, the size of the atom decreases. And this has to do it. The same thing apply to what? Period what? Period 3 and period 4. Just as the same thing apply to nitrogen, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Just as the same thing apply. So this is it for what? For across the period. Now let's look at down the group, the atomic radius down the group. What happened to the size of the atom down the group? So that's what I'm going to look at now. So look at what the atomic radius down the group. What happened to the size of the atom down the group, right? So we want to take what? This group one here. Let's take this group one. So here we have hydrogen, here we have what? Lithium, here we have what? Sodium, and here we have potassium. So remember, if you go down the group here, the size now, there's an additional what? Shell added. So for here we have 1x, because here is 1, here is 3, here is 11, and here is what? Is 19. So here we have 1x1, here we have 1x2, 2x1 here, right? Here we have 1x2, 2x2, 2p6, 3x1. Here we have 1x2, 2x2, 2p6, 3x2, 3p6, 4x1. Make sure you know how to write electric configuration. Now, what is similarity here? Similarity here is that they have this x1, 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 and x1. And they are in the block X element. They are in the same block S. But they have the atom's electron of 1, 1, 1, 1. So that's why they are in group 1. And they are what? They are in block X, right? Now, what is the difference here? Here we have 1, here we have 2, here we have 3, and here we have 4. That is, this guy is what is in group 1. So that is, this hydrogen only have one shell, one electron shell. This guy have 2 electron shell. This guy have 3 electron shell. That is me. Why they have 4 electron shell? This is because they have 4 electron shell. So this will have only 1. This will have 2. This will have 3. So what happened here? As you move down the group, there is an additional shell added. Because you only have 1, but you have now have 2. You can now have 3. You can now have what? 4. So what happened to the size? Now, what happened to the size of the atom down the group? The size of the atom increases down the group. The size of the atom increases down the group. The size of the atom, which was the atomic radius, increases down the group. So there's an additional shell added to the element as you go down the group. It means that the size, that is, hydrogen is less than what? Lithium, right? When it comes to size, lithium is less than what? Sodium, and sodium is less than what? Potassium. The same thing for this other one here. The same thing here, beryllium is less than what? Magnesium, and magnesium is less than what? Calcium. The same thing the other ones. So as you go down the group, the size of the atom increases. But what about across the period? What happens here? It decreases. This is what you need to know about what the atomic radius, which we call the size of the atom. Hope you understand. So that is everything about what? The atomic radius. Next we're going to be what ionization, what energy. All this video is helpful. So this is going to be the part one. We're going to talk about ionization energy in the next video. I don't want this video to be too lengthy, so hope this video is helpful. If this video is helpful, please give it a like, subscribe to this YouTube channel, and I'll be producing more videos like this. Now, but just that if you're not in our private class, you do not have access to all the videos. You only have access to few videos. But if you're in our private class, don't worry, you have access to all the videos. Just now. So we are going to end here. So ionization energy, electric affinity, electronegativity, all will be done in our private class. Thanks for watching. I don't want this video to be too lengthy. So there will be the word part 3, part 4, and part 5 of this periodic table. Thanks for watching. See you in my next video.